recording. Filmed in front of a live studio audience. Algebra 2, final review. The last one. Because we got finals tomorrow and then we get to go home. All right, so quiz 3. Here's how it works. Okay. I point to the number and I ask, where does it hurt? Do we want to do this one? Do we want to see this one? 10, 1, 1? Okay. 10, 1, 2. Feeling good? 10, 1, 3. Even C, even part C? We're feeling good about part C? Yep. I don't doubt it. That's just usually the one people ask for. 10, 1, 4. Yeah. Yes? Is that, wait, have I heard a yes yet? Sorry. 10, 1, 4, 10, 1, 3. We're good. All of them are good? Yeah. Oh, okay. Got it. Okay. I can pause for station identification. We're good. Okay. Ten, 1, 5. I figured 10, 2, 1. Q1. I can. It's not a big deal if we start there. And even if you already know it, it can be healthy to help out with later. Everybody's good? Okay. I figured, but again, it can be helpful. 10, 2, 2. Do we not only do we understand how to do it the long way, but do we understand how to do it the quick way?
Can we go through it real quick?
Yeah. That's what I want to hear. So, first of all, the roots, baby. It's all about the roots. We're going to figure out what numbers make this equal 0 when we plug it in for x. Now, unless you're big country, you should not be even big country should not be big braining this. The easy way to solve this problem is to turn it into a multiplication problem. Factor it, right? So we know that it's going to be x times x. And we have a negative number here, so we need one of each, right? A positive and a negative. And it looks like the positive is going to be the bigger one, magnitude-wise, because we're going to come out to 10 when we add them together. So far, so good. Factors of 96 that are separated by 10. Because if you think about it, when we take a positive and a negative and put them together, we're really doing subtraction, and subtraction is distance. So I need numbers that multiply to 96 that are separated by 10. Well, obviously, 1 and 96 ain't going to get the job done. They're way too far apart. 2 and 48, again, just cutting this in half and doubling that one, right? Potato, potato, is closer, right? They're not quite 95 apart, but they're still not 10 apart. But what we can do is we can work from here, and I was showing Bree this earlier. If I know 2 and 48 works, again, I can double this and have that to get some more. Again, not separated by 10. Double this, have that. And now they're too close, right? They're separated by 4. So I know that the factor I'm looking for is between 4 and 8. Now, 5 ain't going to happen, right? 6, on the other hand, will. And here's how I know. Because 6 goes into 60 10 times. Are you following me on that? So 6 times 10 gets me 60. There's 36 left over. Does 6 go into 36? Oh, yeah. So if it goes into 60 10 times and 36 6 times, it'll go in 96 16 times. And that's the one we need, because they're separated by 10, aren't they? So 6 and 16. Now, Bree mentioned earlier and figured this out, right? It does matter where they go, because if I put the 16 here and the 6 there, I get negative 16x's and positive 6x's. That's going to be negative 10x's, right? I want the other way around. And it is important to note while we're here that just flipping these will change this sign, but nothing else, right? I'll get the same 96, I'll get the same x squared, but depending on where I put them, I'll either get positive 10 or negative 10 there. So I'm going to put a positive 16 here and a negative 6 there. I'll pause for station identification. How do we feel about this? Working your way through it to kind of give yourself a for instance, right? We know it's between here and here. And so now our roots are the answers that make this equal 0. Well, when x is negative 16 or when it's 6, we've got winners. However, we are not finished. They want us to find the sum of the roots. Well, these are the roots. These guys, the ones I circled. So if I sum them, I'm adding them. Looks like the sum is going to be negative 16 plus 6. It's going to come out to negative 10. I almost said positive. And then the product is when I multiply them. Well, that's going to come out negative. Looks like negative something. Negative 60 and negative 36. Negative 96. Where have I seen this before? And again, that's the question. What do you notice? Because the shortcut here is very valuable. The sum of the roots is just your coefficient of your linear term, but the opposite. So if ax squared plus bx plus c is our general form of a quadratic, the sum is just whatever the opposite of b is. And again, I say opposite, not negative, because Shaina pointed out earlier, literally like 10 minutes ago, that if this were a negative 10 up here, then the opposite of b would be positive 10 down here, right? Making something negative, or I should say negating something, doesn't always make it negative, right? It just changes the sign. How do we feel about this idea of the opposite of b? Okay, I'm still here, Netflix. I'm still here. Stay in the call. And if you also notice, the product is literally c, right? So it comes from here. And we don't change any signs. So guess what? You don't have to do any of this now, do you? Ta-da! But the reason we did it is because that's where it comes from, noticing things as you're doing stuff. It's not necessarily a formula we throw out. And again, this 2-2 thing slash chapter or section 4 thing was like literally the Thursday before we headed into portfolio and presentation stuff. So it shouldn't feel super fresh, but how do we feel about this? That's why I'm kind of taking my time on it, because it's not really review, right? This is kind of, hey, we saw it up here, just a smidge, right? Cool. That's going to be essential for the next page. How do we feel about 10-2-3? Did I give you all a copy of this?
I have one already. I have one.
Is it the same?
No.
Oh, would you like the same?
I would love the same.
I mentioned this earlier. I'm really tired, so sorry guys. I'm not like here in this moment. But I'll do my best. So earlier I mentioned you don't have to write anything down if you don't want to, because I can literally copy that and then give it to you, and you can use it tomorrow. Does that make sense?
Yeah.
So you can watch the show. Alternatively, I have extra copies. Would you like one?
Sure. I would love a
Okay.
copy.
Yeah, no shame.
I do better when I like write down my own
Yes.
stuff, because sometimes I have trouble like deciphering your stuff.
Yep. And that's why I lay out the options so you can make an informed choice. Okay.
Plus I have my preferred highlighter.
Oh, thank you for going down, son. All right, so feeling good about 10-2-3? It's a little different than the last one. The last one was a little more complicated, right? It had the negative sign here for the x, yeah. Okay. Yeah, sorry I didn't get that to you right at the beginning. 10-1-6 Q diamond. This one's supposed to be really hard. It's actually super easy, but if you don't know what to do, it can be kind of confusing. Would you like to see it?
Yeah.
Okay, so let's look at the, no, you don't need to be sorry. So when does this product equal 0? Well, this is really just the same thing we've been asking, right? Because this is something times something times something. So you know if I'm multiplying and I get 0, the only way to do that is that one of these things, at least one, has to be 0. So when is this one 0? When x is 4. When is this one 0? When x is -3. When is this one 0? When x is -4. And any one of those will make it 0, right? If I plug in 4 for this one, I get 0, I get 7, I get 8. But again, who cares what those are, because 0 wins the day. If I plug in -3, same story, but from the middle. If I plug in -4, same story, but from here. The real question, the one that you're probably stumped on, is how do we expand the product? So if I were to give you 3 times 4 times 5, I bet, well, I cannot guarantee, that you would not do 3 times 4 and then do 3 times 5 and then multiply those together, right? You wouldn't do 12 times 15, right? You just do 3 times 4 and then times that by 5, right? Or whatever order you wanted to do it in. Same thing here, something times something times something. Multiply in any order you want. We're not doing this times that and that. However, you can do it in any order. So you can do this first, which a lot of people do because they're right next to each other, right? Like you would do 3 times 4 first. However, can I show you something? What do you notice about these outside ones?
They're like opposite.
Do you remember from the first page what happens when we multiply opposites like that? The middle term goes away. So if I'm clever, I know that this, when I multiply that, and I can multiply in any order I want, right? It's multiplication, ends up being x squared minus 16. Right? Because the middle terms go away. The linear term. So that one's faster. I like that. And then I've got x plus 3 that I still have to multiply by, right? They're still in parentheses. These are quantities, right? We're treating them like numbers. So now it's easier because I have less terms, and I can just distribute the x squared to the x. I get x cubed. Are you following me on that, right? X times x is what this is. When I times it by x, I get x cubed. Then I've got x squared times 3, which is 3x squared. And if I'm going too fast, please slow me down. Okay, you guys are writing, and sometimes I forget that. 3x squared. I'll pause for station identification. Hi, you're watching the Mr. Mac channel, Mr. Mac's ASMR. Welcome to math for the people. All right, back to the math. So I've distributed the x squared. And now I'm going to distribute the negative 16. For those of you that have already done this problem, you can compare your answer to mine. Mine's just, I don't have to get terms together when I'm done, which is nice. I don't know what that means. External. Okay, good. Sometimes I get called about that one place we ordered shirts from last year for Pep Band. And they call like during class, and it's like, I cannot buy shirts from you right now. I'm currently teaching. So they've started calling after school, which is better, but I still kind of hate them. Sorry, YouTube.
They also took literally forever.
Wasn't their fault, but it kind of was annoying. Okay, anyway. Here, negative 16 times x is negative 16x's, and then negative 16 times 3 is going to be negative. Get that out of the way before I forget it. Looks like 30 and 18, so 48. Are you following me when I do that? 30 and 18? Okay, good. That's a super useful skill that we do not teach enough. So you'll notice with my method, because I did these outside ones, because they're there. Maybe they won't be next time, right? But if they're there, I picked those two to do first. That way I'd have less terms. And then look, now I don't have to simplify anything. It's all together. If you had done this before, you might have done just left to right, and you would have gotten like some x squareds, a couple of x terms. You'd have to combine them at the end, right? How do we feel about 10-1-6? Okay. 10-2-1. Okay. Quick advice. Divide everything by 3, right? And rearrange it in a way you understand, right? Cool. B. As in Bartholomew. Part B. Do we feel good about that? Double everything, right? 2t squared ain't scary, right? It's just 2t and t. Okay. Next page, 10-4. The reason for the season. I'm so excited about this one. Can I show you this one?
Yeah.
The sum of the roots of the quadratic is negative 5. Remember from the last one we did about sum of roots and products? The sum was the opposite of the linear term. So if that's my sum, my linear term is going to be this. Has to be, right? And the product is negative 126. Remember, the product was literally just the last term, the constant. And assuming that this is just a quadratic with, no coefficient here, that's what it should look like, right? Ta-da, that works. So now what are the roots? Well, we have to solve for that, don't we? But it's not too bad. I'll go down here. My head will go away. I know it's going to be x times x to get x squared. I know I need one of each because I have a negative sign here. So that means I need numbers that multiply to 126, and they're separated by 5. Well, I'll list some out. Obviously, 1 I'm not even going to list. It's not worth my time. But 2 and 63 I'll write down because then I can think of that. I can't take out a 2 from 63. But 63 is divisible by 3, isn't it? How many times does 3 go into 63? 21, because it goes into 60 20 times, right? So I can rewrite this as 21, and this is 6. Are you following that logic? So 6 and 21, are they separated by 5? No, I got to keep going. Well, I can take out a 7 or a 3. Let's take out the smaller number so we don't overshoot. I'm going to take out a 3 and get 18, and then this becomes a 7. They're separated by 11. We're getting close. What if instead of taking out the 3, I took out the 7? Well, if I take out the 7, I get 42 and 3. That's too far apart. Again, I'm just kind of listing them. If you want, you can go in order. We've got 2, 3. Does 4 go into 126? Well, 4 goes into 120, so it can't go into 126, right? 5, no. 6, got it. 7, got it. Might have missed that, right, if we weren't thinking like this. Ocho. Can 8 go into it? Well, 4 can't. 8 can't. 9, perhaps 9. 63 is a multiple 9. So I could take out a 9 instead of taking out a 3 like we did, right? So if I take out a 9, I get 18, and this becomes 7. Oh, I already did that one. Darn it, I did 3 twice. 42 by 2? I'm sorry, what do you mean? And I know, and then I can divide that to get back to this. That's true. I'm just making sure I'm not missing any. So I already got this.
Since you took out the 9, what if you took out the 7 instead? So you were left over.
If I take out the 7, there's what I'm looking for. 14, and then I'm left with 9. And then we have separation by 5. There it is. Right? I would have got there. It was the next number I was going to check. My advice is to do this, but also try to do it in order, like 2, 3, 4, 5, 6, right? So you don't miss any. But like, I don't know. It's not my style. So we've got this. Now the question is, do I want the 14 here or do I want it there? Well, I want the 14 to be positive. So I get a positive 5 when I add them together. Because that's the original problem, right? Sorry. Right? So this is that, meaning if I solve this problem, I've solved this problem. And this is a much easier problem to solve. X is negative 14. X is 9. And we can double check to make sure we got the right thing here. Is the sum going to be positive 5? When I add these together? No, it's not. But that's okay because we wanted it to be negative 5, right? Remember, it's the opposite. And then this, will it multiply to negative 26? Oh, yeah, it better, right? That's how we got it. So, yep, we had the right idea, and we found its roots. How do we feel about that one? Okay, because that's going to be essential when we talk about one that is like 10.4.2. I think it's the reverse of that. If you understand that, we'll be ready for what that red is on the middle board right there that Shina was asking about earlier. All right. 10.3.1. Come on. You want to see them, right? Come
Can we
on.
go through like...
Yes!
We don't need to do all.
Okay, you can pick C, D, E, or F. Don't say F, 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 don't say F. Which one? Which one?
I see.
I'll do C. Or I'll do F, I mean. Sorry, you wanted F, right? Okay, we'll do F. Big Mo. I think this will be fine. Okay. So, first things first, this looks like a bunch of mess. And if I make it look more familiar to me, I might be able to solve it better, right? That's a problem-solving technique. So 15x squared is fine where it's at. But I'm going to get my x's together. And the way I want to do that is get them over here, right? So they're all on the same side. So I get equals 0. So I'm going to subtract 38. Instead of subtracting 38, I'm going to subtract 8 first and get 1. And then I'm going to subtract 30 and get negative 29. That's just how I'm thinking about it. Again, 9 minus 38 is negative 29. Don't forget your x's. And then we get negative 14 when we move that over. So far, so good? Yep. Wonderful. Now, why is this part F of an intermediate question? Because unlike all the others, which we can divide out, or it's like, oh, we can't divide out, but we'll do a 5 and a 1 and we win, right? This has options, right? We can factor this as 5x times 3x. Or we could do 15x times 1x. Does that make sense? Now, the good news is we probably don't want a 15 because this number really isn't that big, right? So we probably want 5 and 3. Not guaranteed, though. Okay, I'm just telling you how I'm thinking about this. I know that since I need a negative here, I need a negative and a positive down here, right? Now, I probably, not guaranteed, want the negative sign here. Why do I want the negative here, you think, versus this? Any idea? It's okay if you don't know. Remember, before I add my x's together, this is going to multiply with this thing, right? And the 3 is going to multiply with that. And I want my answer to come out negative, so I want the negative answer to win. Do you see how whatever I put here is going to be times by 5? So it's probably going to be heavier, bigger magnitude than whatever ends up here. Because again, the 5 is going to hit this versus the 3 hitting that. You smell what I'm stepping in? Okay. So I need numbers that multiply to 14. And then after this happens, they get 29. Luckily, there aren't that many numbers that multiply to 14. 1 in 14 is a possibility. I put 14 here, way too big, way too small, right? Not going to happen. Put 14 there. 14 times 3 is 42. And then 1 and 5 isn't going to get me that. Okay? So 14 and 1, it's out. What's our only other option? 2 and 7, 7 and 2. If I put the 2 here, I get 6. The 7 there, I get negative 35. That's a winner, right? So I need the 2 here, the 7 there, so that I get negative 35 x's, and I get 6 x's. Comes out negative 29. Can you see that 7? I know that was kind of small. I had to fit it in the circle. I'll do it in black. 7. 2. So now the question is, what are the roots? What are the answers? Well, when does this equal 0? It's not negative 5. It's not negative 3. When I plug in negative 5, this doesn't become 0, right? The answer I want is this. Now, I'm teaching my Algebra 1 kids this, and my pre-algebra kids last year I taught them this. Fractions are division for lazy people. What number do I times by 5 so that I get negative 2, so that when I add 2, I get 0? Are you following what I'm saying here, the logic? Well, this is the number, because when I times that by 5, the 5's divide out. And I get negative 2. And negative 2 plus 2 is 0. Over here, let's apply our same idea. Well, I need 7/3, don't I? Because 7/3 times 3 is 7. 7 minus 7 is 0. I win. How do you feel?
Good.
Wonderful.
We don't need to do another one.
Okay, cool. Next, consider the expression 1032. How do you feel about letters? It's the same logic we used before, right? Negative m over p will be the answer here, and negative r over n. I reversed those, but you get it. 1033. Yes? China, you needed to see this, and so did Bree just before you came into homeroom, but now you're probably good. What do you notice about this and this? They're the same thing except what?
One is the linear term is negative.
Vocab word. Very good. So notice that we have the factorization for this one. We don't have the factorization for that one. However, I know that 14x and 5x will get me that 70x squared, if this is true, which it should be. And 9 and 7 get me the 63 that I also need down here. But notice I need my linear term to be negative. So guess what? There are 2 ways to multiply to 63 with 9 and 7. Double positive, which is this one, and double negative. This one needs double negative because the middle's negative, right? So there you go. What are the solutions then? Well, guess what? They're these solutions. I need 9 over 14, positive, and I need 7 over 5. That's nice. That's nice. How you feel? Wonderful. Am I going too quickly?
Not really, but can we take like 2 seconds?
Yes. Absolutely. Please let me know if I'm going too quick. I'm like trying to respect your time, and so you know what I mean? I'm caught between that rock and a hard place. I don't want to bore you guys. I'm always worried about that. Bum, 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 bum.
I have so many like half-empty water bottles and so many like cheeseburger wrappers and football games.
Because you dove into Narnia.
Basically. I'm good.
All right, cool. Awesome. Next one. Find the sum of the solutions. Well, one method, and again, this is definitely a big country's alley, is to find it by factoring, and then you get your solutions, and then you sum them, right? You add them together. This looks scary. Why is this scary, first off? Well, 48 has lots of factors, so we could do 48 and 1. We could do 24 and 2, right? It's nasty. We could move it over to make it not negative. That's not a big deal.
Can we divide everything by 3?
We could divide everything by 3, and that make it a little bit better, right? And you could brute force it that way. And originally, if I were to give this problem in class, and we kind of did something similar to this, you would brute force it, right? And then you'd be like, God, there's got to be a better way. And I'd be like, yes, now you're ready. You're ready, okay? So guess what? Before we found out, when we had, I'll cross out that A. When we had this, the sum was this, the opposite of B, right? Not necessarily negative, right? If it's negative here, it's going to come out positive there, right? It just flips the sign. Whereas the product was just literally whatever C is, right? Are you scratching? We understand? Okay, cool. I am going to write this on a separate sheet of paper to explain this because I did it on the backboard there, but I want it for posterity on the YouTubes. Okay, so let's logic a little bit. How do I go about this? We'll start here. Imagine I have factored a quadratic. That's a C. That's a D. Okay? Imagine I have factored a quadratic, okay? Are you with me on this? So the solution to this would be negative C over A, or it would be negative D over B. Are you following me on that? Okay, cool. Those are our solutions. If we wanted to find the sum then, we would do this plus this, correct? We just add our solutions together. Now, that's valid. What's up? Are you here to watch or you...
Well, all my stuff's in here.
Okay, grab it. So if I'm adding these two, that would get my sum, right? My two answers? I can't add them as is, but I can circle that and be like done with it, right? However, if we play around with it, I want to get common denominators, right? If I've got 3/4 plus 1/5, you know one way to get common denominators is times the bottom and top by 5 on one side and the bottom and top by 4 on the other, because then they'll match. Let me show you what I mean. If I times by D over D to here, the denominator is now AD, right? And by D, I mean B. Sorry. D is for Listexia. Right, now we've got AB. Over here, I'm going to multiply by A over A. See how the denominators are going to match? Right? Now, the reason I'm allowed to do this, by the way, what is A over A?
1.
I'm timesing by 1. Does that change anything? No. This is no, I did it to both sides. There aren't two sides here. There's no equal sign. Right? The reason I'm allowed to do this is because it doesn't change anything. That's why you have to do it to top and bottom, because you have to do it like this, so you're timesing by 1. Do you follow me? Wonderful. So when I do this, I get this AB, because alphabetical order, yay. Shout out to Abby. And then this becomes negative BC, and I'm still adding, I haven't done it yet, AB negative AD. And because they have common denominators, you know how that works, right? If I have 3/4 and 5/4, I can add them together. They're all quarters. These are all ABs. And again, this is kind of the Y, so bear with me. When I add these, I get this plus the negative version of this. And that will be my sum of my answers, of my roots. Okay, do you buy into that? You don't need to like write all this down necessarily, but do you buy into the concept I'm selling? Okay. So knowing that, what is this number? Right, because if we had a shortcut, I would have a shortcut to be able to get the sum every single time. Now, check this out. AB. What is AB? Well, if our quadratic is this, you might have said the answer and I couldn't hear you, Maya. I'm sorry, it was rhetorical, but like you might be right. We're going to find out. I won't make you repeat yourself. Imagine this came from here. Notice A, B, and C are capital. They're not the same thing as A, B, and C down here, okay? Where did AB come from? Little a and little b. They came from here, didn't they? So what is A times B? It's big A. Big A. Negative BC plus negative AD. Well, let's focus on one term at a time. Where does BC come from? Here. And where does AD come from? Here. And when we add them together, it's our linear term, isn't it? Now, these are not AD and BC. They're the opposite. Oh my God, it's the opposite of B. So guess what we just figured out? The sum is not always the opposite of B. It was the opposite of B on the first one because we didn't have an A value here. We had a 1 in front of here, didn't we? So we got negative B. We were that close. We were that close on a Thursday. We were so darn close to getting... I love this part. I love this part. The payoff, man. It's right there. But we had presentations. Sorry. Had to do it. Semester 2. This is super useful, right? Because now we have a formula that makes sense of where we get our sum from. It's negative B over A. Do you want to do the product? You want to do the product, right? It's not the question, but we want to see the product. It's C over... okay, yeah, we're going to get into that. It's C over A, right? Think about it. What is the product? When I times these together, think about it. When I times them, negative and negative makes a positive. I get CD. over AB. Again, I'm not adding, I'm timesing because we're talking product. You follow me? AB is just big A. CD, where does that come from? It's big C. Oh my God, isn't that fun? Do you get tingles? I get tingles. I didn't know that till I started teaching this book. I was doing it the hard way. I had a magic X method that I taught kids. It was kind of a trick to get the right answer for these things because factoring's hard, right? But I never knew why it worked. And then I got this book, The Art of Problem Solving, and I went, God, this is amazing. I love this book. Anyway, now we know this. Guess what? I don't have to factor this, find my answers, and then multiply them. I can literally just take the because we're doing sum. Are we doing sum? Sum. We're doing the sum. So that's coming from the B, right? Remember B, it's the terms that add together, right? Or X's get together. So it's the opposite of this, which is 24, divided by A. It's this. Shine asked me earlier, should I simplify that? First of all, no, I don't care. Second of all, no, because what does this tell me? If you were to write 12 over 24 or a half, I might think you did it the hard way and added them together, right? But if you do this, I know you did it the good way. This shows understanding. I know exactly where you got this answer from. Good job. I'm not requiring this one on the quiz. I'm not. But it's fun, isn't it? I like it. Are you ready for 10-4-2? It wants to know the product. I thought about using the exact same equation, but nah. Right? Let's make them run through it again. Because maybe you'll notice something on the way, right? Maybe you'll do all that brute force and you'll notice a connection. That's where I did. That's how I came up with it first. So anyway, I know the product is going to be from this guy, right? And it's going to literally be this over 76. Because that's where our numbers come from, right? Again, all of this has been in prep to get your brains ready to think and notice things about math rather than just here's a formula. If I gave you the formula, like a lot of math teachers probably do, you'd probably forget it. And how do I know that? Because I forgot it and I'm literally a math teacher. But when you see it like this, it affects you. And I think that's worth it. Moving on. 10-5-1. I don't want to do it. Maybe you could talk me into it. I don't want to. We haven't talked about it yet in class. Does that make sense? I need to scratch that itch before there's a metaphor there. 10-5-2. I'm breaking a rule. Remember how I said I'm not going to do anything with a 5 in it?
Yeah.
You're actually ready for this one. You're ready. And so I want to do it. Okay. So check this out. Every day you guys have been wanting to solve these equations before you started factoring, and you're like, okay, I guess. You wanted to root both sides, didn't you? Right? You wanted to get x squared on its own, root both sides, and go to town, and then algebraic nonsense ensued. Oh my God. We'll talk about it later. But guess what? We're going to do something. I'm going to square both sides, which is way easier to do than rooting, by the way. It's kind of like multiplication and division. Multiplication is just easier. Anyway, I'm going to square both sides. Think about what squaring means. It means times it by itself. Well, if I have the root of a number times the root of a number, I get the number inside the root, right? Root 25 times root 25 is 25. So the root of x plus 7 times the root of x plus 7 is just x plus 7. Are you with me on that? Now I have to square both sides. And what's kind of cool about squaring is that while I times this side by the root of x plus 7, I didn't times this side by the root of x plus 7. I'm timesing this side by 5 minus x. Now let's think about that for a second. Why is that legal? How am I allowed to times this side by the root of x plus 7 and times this side by 5 minus x? Right? How does that stay balanced, right? If I times one side by 8, I should times the other side by 8. I'm getting into semester 2. This is a question we're going to have to investigate, but I just can't stop myself. Why does this work? Why am I allowed to do this? Where I times this side by the root of x plus 7, and I times this side by the quantity of 5 minus x. Instead of timesing by 8 and 8, or 12 and 12, or...
You're not. I know it, but I don't know how to.
You're onto something. Can I tell you?
Yeah.
If I multiply one side by 8 and the other side by 4 and then by 2, does that stay balanced?
Yeah.
Why?
Because 4 times 2 is 8.
What if I told you the root of x plus 7 is 5 minus x? What if I already told you the call's coming from inside the house? Isn't that fun?
That is fun.
They are the same, so you can do it, right? Isn't that beautiful? I love that. Anyway, this means times it by itself. You know what that means. And if you know what it means, you're not going to be confused about what 5 minus x quantity squared is. Again, understanding what it means reveals the answer. A lot of people tell me this is 25 minus x squared. It ain't. What is it going to be? 5 times 5 is 25. 5 times negative x is negative 5x. Hey, we get another one of those. They don't go away. They're the same sign. And then we get negative x times negative x. Negative times negative is a positive, so I get positive x squared equals x plus 7. Oh, I love this question. So what's x going to be? Well, I don't know yet. Leave me alone. Give me time. I need time to process. You know what's a terrible idea in real life, but a great idea in math? We're going to get our x's together. So I'm going to move that x on over. And I'm going to move the 7 on over. So I get 0 on this side. When I subtract 7, I'm going to subtract 5, then subtract 2, I get 18. When I subtract x, I don't get negative 9x's. I get negative 11x's. Oh, wait, is this one the bad one? No, it's the good one. This one should be a good one. Okay, good. Sorry, some of these don't have nice answers because, like, I'm tired, man. But, like, if the answer is the most important thing, I'd feel really, really bad. But, like, if you get this, like, I don't care what the answer is, man. Anyway, I'm gonna rearrange this so it looks more familiar, because familiarity is a useful problem-solving tool, and that's literally the whole point of this class. It just happens to be math. We could factor this and solve for x, couldn't we? At least in theory, that one's not factorable. Maya, you know about prime numbers, right? 12 ain't prime, it's composite or not prime. You can break it down, you can factor it, right? 7, it's prime, can't factor it. Some equations, believe it or not, most of them, are actually prime, meaning you can't factor them. This one, we're gonna pray that it's factorable so we can finish this awesome problem with an answer. Thank God. I need 2 negatives, right? Because 2 negatives multiply to make a positive, and they'll add to a negative number. What numbers multiply to 18 and add to 11? 9 and 2. So x is 9 or it's 2. Now, a word of caution, if you will. We messed with this problem a lot. We multiplied by things. That can screw things up, it turns out. And if we did pre-algebra together, you would know this, but that's okay. We didn't. That's fine. That's fine. I wasn't here. You weren't there. Wrong time, wrong place. Our paths just never crossed, but now we're here, right? So we should check, and maybe it'll be fine, maybe it won't. Do both answers work? Because you know roots can come out negative or positive, and that can be a problem sometimes. So let's just check, just to make sure. Again, I'm not prepping you for this. It might be fine. If I plug in 9 in the original problem, does it work? I get 9 plus 7, which is 16. What's the root of 16? 4. And it is not negative 4, it's positive 4. There's a difference there. I remember asking my math teacher about this. How come sometimes it's negative and positive and other times it's not? I'll have an answer, but not right now. 5 minus 9 is negative 4. So 9 actually doesn't work. We call this an extraneous solution. Now, okay, so sometimes you get answers that don't work. And that's because, spoilers, math is not objective. It's not. Why are we not allowed to divide by 0? Because it makes math weird and not useful or interesting after 5 seconds of going, anything can equal anything, right? So we decide as mathematicians, we call it undefined. If you define it, it screws up everything else, so we'll leave it undefined. We define square roots to be only positive when they're in the problem. When we put them in, we have to account for both, because we inserted that, right? But in the original, we define it to be only positive. It makes things work out nicer. Is it wrong for it to be negative? No, we're mathematicians. There's no wrong, there's no right. It's what's interesting, what's useful, what is your cup of tea. So, traditionally speaking, we interpret this as being only a positive answer, which is why this is 4. This has to be negative 4, right, when I plug in 9? So 9 is not a solution. It's 2. Root of 9 is 3. Positive has to be, right, because we define it that way, because society, we live in a society. 5 minus 2 is 3. So guess what? There's only one answer to this one. And that makes sense, because if you think about it, this isn't a quadratic originally, is it? It's a square root problem. Quadratics have 2 answers, but square roots might or might not. In fact, they're defined to have 1, and it's positive. How do you feel? Do you feel tingly, or is it just me? I feel like we've made a connection.
I feel it too.
We made a connection.
I feel God.
I feel God in this Wendy's. Thank you. Okay, 5.4 is also kind of fun. We could stop, but who's to say? Okay? Okay? What if there was just one magical night, okay, where we just said, you know what? We're gonna go for it. What if we did that? Can we? Or are you not feeling it too? This is kind of awkward. I'm putting myself out there.
I appreciate your vulnerability.
Okay, thank you. Okay. I'm glad you understand my humor. Thank you. Rubber band. God, I am tired. I didn't think I could do this justice. I was so tired today, man. I was at school at 4 this morning. All right, if the sides of a square are each increased by 8 inches, imagine, if you will, a square. It has unknown sides. We could call it X. Square X. And I increase it by 8 inches. Well, we used to be here. Now I'm drawing an arrow. This is very Richard Feynman of me. Okay, so now it's 8 inches bigger. Do you agree that X plus 8 is 8 inches bigger than it used to be? Do you understand this concept? If I'm X before, now I'm X plus 8, I'm 8 bigger. Cool. The area is increased by 128. Okay, hold on. The original side length, I get it. It's X. We had 8, now we're bigger than X. Bigger than it by 8, right? The side length has increased by 8. What was the original area?
Great question.
What's the original area?
X squared.
It has to be, right? So when I say the area got bigger by 128 inches, what I'm saying is that now our area is the original area plus 128 inches. Can you see that? Is that kosher? Okay, wonderful. Big mode. So what is the length of the original square? How do you solve a problem like Maria? We need a relationship here, okay? How are these related? Well, x times x is x squared. That's an equation, but that's not really useful because I already knew that. However, how would we find the area of this thing? We knew it relates to this, but how does the area of the square relate to its side? If I told you the side length was 5, you'd tell me the area is 25, right?
It's 2 times the
Words are hard, but I know what you mean. You times the side by itself. So in other words, you know that x plus 8 times x plus 8, or x plus 8 quantity squared, has to equal x squared plus 128. And that's profound. X times x equaling x squared is kind of like a definition. This isn't always true, right? It only works if x is a certain number, whereas this is always true no matter what x is, right? So that's not super useful. Here, this is going to help us figure out exactly what x has to be. X times x equals x squared could mean anything for x. We agree, right? That's always true for any x. This is important because it's unique, meaning only one number for x, or 2, should work for this, right? Not any number works. Any number would work here, right? I want to find the number that's here. So let's do it. We know how to do it. Distribution. They don't go away. Is it okay that I'm shortcutting this? Oh, God. It is if I do math right. 64. And by math, I mean calculation. They are not the same. Calculation is stupid math. Math for dummies. Anybody can calculate.
Math for me. Math for me.
No. You are mathematicians in this class. You are not calculators. There's a difference. At least we're on our way to becoming that. So now I'm here. Guess what? I have a number plus something equals the same number plus... I can just kind of ignore this. Or in other words, I can subtract x squared from both sides, right? Like, think of it as a balance beam. I can just take off both these weights and it'll still be balanced, right? So I know 16x plus 64 equals 128. That's a problem I can solve, right? What number plus 64 gets you 128? 64. So just using my brain without doing any algebra, I know this has to equal 64. Pause. Look up here. I know this has to be 64. Why? Because something plus 64 is 128. 64 plus 64 is 128. So I know 16x equals 64, which you could have done by like moving things around and doing like PEMDAS or whatever, but like, I don't know, use your brain. What times 16 is 64? It's 4, because 40 and 24, right? So guess what the original side length was? It's 4. How do you feel? Gucci gang. I don't know, or whatever the kids say now.
Oh my God, that's all we need to do.
Ronald McDonald. That's it. This is the easiest, hardest class you'll ever take, or the hardest, easiest class. And I wish, because I used to do this. I used to do the spiel, right? I'd start out with the show. I'm pretty good at it, right? But it doesn't work for most people. You have to have them itch before you teach them how to scratch it. If I come in here and I say, here's what we're learning today, no one gives a care. Because no one asked, right? How do you do this? What does this mean? Now you're ready to learn. And that's why this is so effective. It's not because I'm really good at the show, although I am. It's because you're ready. And it's a combination of being the end of the semester, right? But already I want to learn now. And that applies to you guys all the time, but it applies to everybody else this week, right? But it also applies because you got stumped on it. And it took me forever to figure that out. How do you get kids to learn? How do you motivate them? The secret is you don't. What you do is you put a problem in front of them, and they can't help but try to figure it out. That's why at the beginning of the year when we did like weird problems, like, did we do that this year? Did we do that?
Yeah.
Right?
Right.
Right. I throw it up on the board, and you can't help to think about it. And that's not just you guys, the select few, the sacred, right, amongst us. It's everyone. Why is that? And then, I had a hunch. That's how we get them in. We got to pique their curiosity. But it's hard to do that with this type of stuff, right? Anyway, I'm getting better at it. Because I think it's worth it. That's quiz 3. Baby.
I've been trying to do it, but
We have to stop at some point, okay? We have to stop at some point, but I'll do it. I can't stop. Just one more, man. I can quit anytime I want. I'm on math. He's got jokes. All right, and you gotta to teach this thing, because, God, this is math. Everybody else gets an easy subject to teach. I have to teach math. Okay, anyway. Other subjects teach themselves. History. Intrigue's built into it, man. It's how we got here. Math and quiz. Anyway, what do you notice? The first thing you should ask as a mathematician, especially on an advanced problem, is what do you notice? What do you see?
They're equal to both sides are equal to each other.
Oh, that's good. We have an equation. And it's got a question mark at the end because it's part of a sentence. That's kind of fun. What else do you notice? Look closer. Oh, God. Get rid of this. We don't care about that. If you don't see it, that's okay. It's like an optical illusion.
It's the same thing. You're multiplying by the same thing on this side, and then you're multiplying.
These are the same. Like Danny and... and we know how these are related, right? Same factorization, different signs. This one's double negative. That one's going to be one of each or something, right? Something like that. Oh wait, actually, this might not work out right. We're gonna try it. Okay, we're gonna try it. Sometimes I miss a negative sign. Anyway, we'll try it. Hello.
We made you a Christmas card.
I try not to ask questions I don't know the answer to, but whose hands are these?
I don't know.
Here. Let me see for a second. This one is mine, and this one is Eli's.
Oh my God, this is like one of those moments where like, it's like the Footprints poem with the Jesus thing, and that's when he carried me.
This one's for Vicky.
Except this is weird, and like the SpongeBob thing where it's like twins.
Okay.
Wow. I'll cherish this forever because I'm an idiot like that.
Okay.
Thanks for writing your name on it so I know who it is when I'm old and senile. So tomorrow, right now, in this very room.
Me too. It's okay.
Oh my God, I'm running out of space. Okay. I'd have more up, but my basement flooded. It's all sitting over there. I didn't have time to set up my classroom this year. I was too busy bailing out my basement at the beginning of the year. Anyway, back to this thing, right? Back to the math. Come on, let's get to the fun part. So if we get this one, we get this one. And by that, I mean we factor, right? If we turn these into multiplication problems, which they kind of already are, right? Something times something will equal something times something. If we turn these into multiplication problems, we can figure things out. Imagine I had this. 8 times 4 equals, and this is where I have to pull an x because otherwise it won't make sense, times, oh God, wrong color, times 8. Couldn't you divide both sides by 8? 4 is x, right? I'm going to divide by this. I'm going to divide by that. I don't know the answer to this one because I haven't looked at it yet. I just haven't, right? I'm just spitballing here. But that's my logic. What do you think? Okay. Cool. So I divide those out. I know this equals that now. I can factor these things and find out when they equal 0. So in other words, I'll do this. And you're probably wondering, why do we care whether it equals 0? This equals this. I'll explain in a second. We don't actually care about that, but this is what I'm thinking. Numbers that do this, and hopefully it's factorable, right? I haven't double checked this one. This is review guide, not test. I need numbers that are opposites, and I need the negative to win. 52 and 2, 4 and 26, we're getting closer. 8 and 13, there's the winner. Separated by 5, yeah. Equals r minus 13. I wanted that one to be the negative, I think. Darn. See, this is why I got to double check these things, which I will tonight. Again, I checked them last night. I'll check them again tonight. And if they're ever like goofy like that where you can't get a nice solution, that's okay, other than it wasted your time a little bit, and I apologize for that. But you get it for free, basically. Because again, the answer is not the important part. And here you can get the answer wrong, but have the process 100% right. And the process is what matters because the process shows understanding. The answer shows I got the right answer. For instance, not naming names, but there's a really hard question that's an advanced question that somebody wrote 420 and 69 as like favorite numbers for these two people. That might have been the answer. How did they figure out? I have no idea. That's all they wrote, right? They got it right. Does that show understanding? No, it shows they know who I am. And that, yeah. I try to have fun. If you're not having fun, what are you doing, right? But anyway, right? Do we understand? Cool. Awesome. Moving here. If I divide both sides by r minus 13, because that's just a number, I get 1. So when will this equal 1? That's a tough question. What I really wanted this to be was the same thing, because if these are the same, that divides out, doesn't it? Anything divided by itself is 1, and it's all multiplication and division. You can do it in any order you want, so suck it, PEMDAS. And that means this is our question, right? So r is 8 or 9, isn't it? R is 9. If they were the same. Are you following me? If that was a plus 13, it wasn't. It wasn't a plus 13, it was a minus. If this was a plus, right, this should have been a plus sign. Are you following me?
Sure.
Okay. R is 9. So when r is 9, this side will equal this side.
Okay. That makes sense.
Yeah.
For real?
Yeah.
Okay, sometimes I talk and I'm like, there's no way these words are landing. It's not on
That
you.
doesn't really make sense to me, but it doesn't really need to.
Oh, okay. All right. But like, yeah. And it's not, when I say, I gotta be careful. I'm not saying when words don't land, that's your fault. I'm saying like, I'm hearing myself and I'm going, there's just no way in hell anybody's understanding what I'm saying. That's on me. But yeah, anything divided by itself, right? Divides out, and then we get this. Divides out. This is something times something. Divides out. This divided by 1 is 1. This divided by that is 1. Right, get this. Okay, we'll stop.
Girl, you need a new binder. You need a new freaking binder.
Literally me every day in every class telling that to people.
No, because that cover hers is like almost off.
This happened last year, and that's why I got this one.
It always happens,
And I don't know why.
What might be the common factor? Thinking mathematically. Anyway, he's got jokes. Do you want to take a break and then do 2 and 1, or do you want to go right into it? What do we want to do?
I gotta go pee.
I'm gonna leave if we're done with 3.
You can do whatever you want, man. You can leave, stay, show up late. I don't care.
On 3 tomorrow,
That's probably a good
because
idea.
that's the one that I have to get the most done. So
Yeah.
I'm gonna try to get a lot on that one.
You don't need much. You know what I mean?
Yeah.
Right? It's kind of just pick your
Is that true?
poison. You don't need much. You'll be fine. You'll be fine.
I'll stay for the rest, just to like.
Because 3, you have a lot that you could show. Does that make sense? Right?
Yeah.
Right? I'm not just looking at glass half empty or half full, right? But like that's literally right. Okay, good.
Like most of the stuff that I don't have on 2 and 1 is just like stuff that I don't understand yet.
Right. And the stuff on 3 you do understand, you just haven't shown it yet because you've been trying to get 1 and 2. Right? Yeah. So you're gonna be okay.
Yeah. I
Really?
I just don't like worrying about grades. That's like all I do.
Maya, then we're similar in that. I hate what grades do. They don't motivate.
Mm-hmm.
If I've got an A, I don't need to learn anymore. And if I don't have an A, then why should I even try?
Yeah.
I'm glad you're here today, Maya.
Thanks.
Take care, kiddo. Hi.
Is the meeting over?
No, they're gonna come back for round 2, I think.
What's the meeting code? Zoe wants to know.
Oh, Zoe's gonna be doing it from home.
Yeah.
I sent the link to their email.
She says the link's not working. I can go and get her if you want me to.
I will send another one.
Okay. She emailed you.
Is she in the lobby somewhere?
She's somewhere.
Yeah, she doesn't. Yeah, she's here. She has to be. Okay, that's fine.
She might be here. Who knows?
I know she's here. I have deduction skills.
She's
I will send it to
actually
Zoe.
outside somewhere.
Uh huh.
In
I will
snow.
send it to
She's
Zoe.
making snow angels, you know?
Well, good for her.
Yeah.
Where's the meeting link? That's not a thing to click. This is a thing. Oh my god, please. Copy join info. There we go. There we go. You need the code. I think it's because you're probably not logged into your account. Report abuse. General, no. Where would the code be? Hi. I need to figure out how to get this Meet to work because somebody wants to get on the Meet and they're saying they need a code. I'm guessing they're not logged into their Polo account because you should just be able to click the link and get in.
Sometimes you need a code.
Where do I get the code from? Here, I should.
Should be on the meet.
Here. Like I have this. Is that the code?
What?
This thing right here.
Yes, maybe.
I don't know.
Yes.
It might be.
Copy here.
Yeah, that should be the
Yeah.
Okay.
I
Okay.
don't know how much Google Meet has changed, but that should
I know.
Hello. I think the code is the end of the link. I sent you another email. The CRWQFBW. So that one.
Pretty this purple nose. So pretty.
Oh, I'm sorry. It's pronounced Sir Wugv. It's a G. It's a G, not a Q. Sir Wugv. No. F before B. F before B. Remember your English. Sir Wugv.
Who is that?
Sir Wugv. No, Sir Wugv. I don't know. I don't know how any of this works. It should just be you get on the link. Are you logged into your Polo account? Because if you're in your Polo account, you should...
Probably.
On God. Oh my God, it was 4:20 when I sent you that email. Incredible. Wow. God works in mysterious ways. The Lord works in mysterious ways. I'm so sorry for this delay, everybody from the live studio audience. We'll get this figured out. That's the Meet link.
You have more than I do, bro. Hold on, let me flip to.
Why isn't it work? I think it's an issue on your end. I don't think there's a code.
I
Man.
only have 4.
I am not gaslighting you. I'm just disagreeing with you.
Like, that's basic, but I want to get.
I have a lot of
You need to allow the Meet to use your camera. That's why. Did you not allow it to use the camera? You clicked not allow, didn't you?
I just don't.
You need to allow it, and then you can turn off your camera afterwards.
I have yellow, and then I remember.
All right. No. Better question. Where are you? Is that the library? But in the by the library, I'll be there in a second. You know you you could sit here and watch it live as a live studio audience. You know that, right?
I feel it. Yeah, no, I need to like go through this. Wait, who is that?
Nick.
I think that's actually a really good drawing. I'm not gonna lie. That's actually that's like a legit good drawing. Oh man, I forgot her book. So that's mute mine.
Okay, I need food.
Well, I don't have any more food. Obviously, I ate all of my crackers. I'm trying to clean what we have time.
So I want to go to this. It's like a skills kit for talk.
Cool.
Do you have your question? But it's $50 per person. I want to do it, but I don't know. First 30 participants to sign up will have their registration fee waived. Mom? What day is it? January 22nd. We might have the concert. Ooh, more. Girl, I don't know if I can fit all these in here with my Carmex and my.
Girl, have you ever done Jenga? Right? So have you ever done Jenga?
Yeah.
You can fit it. Don't worry. I have faith in you.
This thing is already thick.
And if you don't have faith in you, I have faith in you.
Girl, you should
Also,
know
did
mine.
Reagan give you back?
She used it. I'm like, I can't bring me
Yeah, because
this.
Caitlin literally walked into Miss Cole's room and handed me my Ken helper. Because it was in the back. I just didn't go down to the end and get it. Because I wasn't going to go down there today.
I need a new quiz one, whatever he's doing. Because I don't remember it, and I haven't had one.
This is like a copy of a copy of a copy of a copy of a copy. Because I haven't taken this since
Oh, it fits.
the like, honestly, so like these are all things that I have ran. This bread.
Top tips are what about?
I do done.
I want to see if I can still make my top tips. Of that blue one, that's so. It doesn't look like it's up.
I can get this, but I'm gonna go. For
What?
because my knee hurts. I'm gonna do some words.
Wake up, and I'm gonna print all your finals and double check to make sure they work out nicely. And that's gonna be like at 2 in the morning. All right. Let me try to send another link.
So your grade now cannot go down, right?
No, can't, because everything's plugged in. So the only reason it could go down is if it's like, hey, we hadn't plugged in the quiz yet, right? But now that it's in, it can only go higher, right?
Okay.
Yep, I know. That's why I try to tell you guys that like every day, but then I end up repeating myself. I'm like, you guys probably hate me. No. You don't need to be sorry. I'm sorry.
If we do go over quiz 1, though, I made a new one. So I can, like, follow along with you.
Yes. Thank you for telling me that now. Why don't I have... Oh, am I not logged in? Hold on. I know what the problem is. It's trying to send me through Google Meet through NotPolo. Let's try this again. This should work. Why is this not working? Am I not who I think I am? I'm not who I think I am. Please stop doing the wrong thing. Sign in. I would like to sign in with this one, please. Oh my god. Alright, this should fix it. Now it won't let me log in. I'm sorry for the delay, everybody. I'm just having technical issues. Nice. Google Meet. Okay, this might work. Am I who I think I am? There's one way to check. I am who I think I am. There's 1, 3, and 8. Okay. And as soon as I do this, we'll be back. All right, friends, are you ready to get going? We're doing quiz 1. Is that the idea?
Yeah.
Uno? Okay. Quiz Uno. Okay. 1 for me, 2 for you. Everybody just kind of knows what's going on, you know what I mean? It makes a huge difference. Like, imagine doing your portfolio, but from the beginning of the year, you're like, I should remember this, I should make a note about this, I'm going to talk about that at the end of the semester, right? Way more organized, way easier to do. But you have to have a dumb semester to figure out how to do it right, unfortunately. It's just how it works. All right, first page. Yay or nay?
I'm good.
I'm also good.
All right, we have someone joining us. That is great. Companion mode. That sounds fun. Second page. Do we need to see any of the basics? Let's do it that way.
Hold on. But I don't know which ones.
Oh, because the sheet is separate. You know why the sheet is separate? I had the speech on my other video. Last year, the kids said the sheet was too cluttered. What if it was 2 separate pages? And I said, sure, we'll make it 2 separate pages. And guess what? It sucks that it's 2 separate pages, which is why I went back. What is companion mode? This is toxic on God. What if I just read everything you typed out loud? It's okay, they can't hear me.
Under.
Oh, hi, I can hear you.
Oh, did you hear me before?
No.
Good. That's probably for the best.
Okay.
I'm gonna hang up.
Okay.
Ooh.
Friends, do you need me to help you figure out what problems we're doing?
Yeah.
Okay. Can I see one of your check sheets?
No.
Yeah.
And I can just use those as reference for which ones we need to look at.
Well,
Because I have these mostly memorized.
well, I don't need these.
Yeah, you don't. Okay, so you don't need basic until here, neither do you, third one. No, we need this. So solving
You look like a-
systems without being given the system. So word problems.
Yeah, no wonder why I didn't get
Cool.
that one.
Well, yeah, but like once you see it, you're fine. So we need to start here with Tweedledum and all that stuff. Okay, so starting here, Tweedledum says the sum of your weight. Okay, well he's referring to his brother. So I'm gonna say X. Oh god. X is gonna be Tweedledee's weight because when he says your weight, he's referring to his brother, right? So your weight is referring to Tweedledee. So this is D's weight. And Y is his own. So Y is Dum's weight. So in other words, he's saying the sum, adding together, your weight plus twice mine. So far, so good?
Yeah.
Is, that means equal sign, 631. Contrariwise, which is a very fancy way of saying, on the other hand, the sum of your weight, and again, this is Tweedledee talking, so he's talking about his brother. So when he says your weight, he means Dum's weight. Okay, that's Y. Plus twice mine, referring to himself, in this case, D is talking, right, is 632. If they are both correct, how much do they weigh together? How much do they weigh individually? So, we can answer those questions. This squiggle means that these X's and Y's are connected. That's what this is. It's a linear system. You wouldn't be able to solve this because there are infinite answers that make this true. And there are infinite answers that make this true. But the combination together, there's only one answer that's going to make both of these true, where they add to 631 here and they add to 632 here. So, what do you notice? How do you want to solve a problem like Maria? Do we know how to solve a linear system? It's been a while.
It's been a while.
Okay.
Was it like you get rid of one of the...
That's elimination, right? Or the opposite is, or the other option is substitution, right? Where we get X on its own and then plug all that stuff in for X. It's whatever you want to do, okay? So I think what I'm going to do, in order to get these eliminated, right, I have to add or subtract. You could, in theory, double everything so that we have a 2x and a 2x, and then we subtract them. But the downside is now when I double this, I've got a really big number over here, right? So sometimes elimination is good. Sometimes it's more hassle than it's worth. I think what we should do is we should do substitution, okay? Because that's going to be more universally valid anyway. So I'm going to get x on its own from this equation. That's super easy. Are you following me to here? That this equation right here is the same thing as the orange equation right there. I subtracted 2y. Are you following me? Okay, so now I know what x equals. It equals all this junk. So I'm going to plug that into the other equation. I'm subtweeting someone right now. So I'm going to plug into this one. Y plus 2 times whatever x is. Whenever you plug in for a variable, you always wrap it in parentheses. Prevents lots of little mistakes. Ask Brock about that. When I plug in for x, I'm going to plug in this. Because that is x, right? If I told you x was 7, you would plug in 7 for x. But I'm telling you x is all this junk. Now, spoilers, we're going to have to double this number anyway. I lied. I just wanted to show substitution because I think it's easier. Or more universally available, or universally useful. So this means 2 times all of that. So if I double all of that, or distribute the 2, I get negative 4y. And I get positive 1,262. And now I've got one equation with one variable. So I can get my y's together and actually solve for y. That's why substitution is valuable. I switched out x for y, right? Something in terms of y. And so now my equation just has one variable, and I can solve. Does that make sense about why we're doing that? Okay. So now I've got y minus 4y. I'm not adding 4y to both sides here. I'm just combining them. That's negative 3y's is going to equal, and to get the y on its own to make this easier to think about, I'm going to subtract 1262 from both sides. The way I'm going to do that is this. I'm going to subtract 2 first. I'm going to subtract 200 next. And then after that, I think I'll subtract 60. So that's 430 minus 60. If I take 430 minus 60, I get 370. Are you with me on that? Yep. 370 minus 1,000. If we take 1,000 from 370, we're going to end up at negative 630. That means y is a positive 210. How you like those apples?
You could have easily just. Okay.
There's other ways to do it.
Yeah.
Ooh,
Instead of doing
we have a guest lecturer. Hello.
Instead of doing
Now watch your
that-
feet.
Instead of doing that, you basically could have just subtracted this, this, and this.
Yes. When you do this, you're not doing 6 minus 3, you're doing 3 minus 6, though, so be careful about that.
No, like this way.
And then change the sign
like,
afterwards?
As in you like turn it upside down.
And then change the sign afterwards?
Yes.
Okay, yes, as long as you change the sign afterwards, yes. Lots of ways to do it. All right, so I know y is 210. Well, if I know y is 210, I can go back and plug this in and get x. Now, luckily, because I'm doing substitution, I already have a nice equation where if I just plug in for y, I get x, right? See how if I plug this in, it just gives me x? Well, if I double 210 and make it negative, I get negative 420. Nice. Negative 420 plus 631 is going to be 211. Yeah, 211. So guess what? X is 211. So that means D weighs 211, Dum weighs 210. And together, because that's what they want to know at last, they weigh 421. How do you like them apples? Feeling good? Not a bad setup, right? And here's the thing. You have notes, which means the setup's free. The only number that changes every time is 631 and 632. That's it. Again, word problems are fair in my class, I say, because I tip my pitches, right? It's all right there. The setup's free. All right, good to go? Remember, I can make a copy of all this at the end and give it to you. You just got to remind me to do it because I will forget. My parents started a small farm after they retired. Aww. On their farm, they have chickens and pigs. In total, there are 188 animal legs among the chickens and the pigs, and there are 75 animal heads. How many chickens do my parents have? So C is the unknown number of chickens. P is the unknown number of pigs. And while we do not know how many animals there are, because that's what I'm going to figure out, I do know how many total animal heads there are. And traditionally speaking, the number of chickens is equal to the number of chicken heads, right? Every chicken's got one head, and every pig has one head. So C plus P should equal 75, because the number of animals will be the same thing as the number of heads, right? Cool. However, it is not traditional that chickens and pigs have one leg each, so what I'm writing now is not true, right? However, what can I do to make this true? If I double the number of chickens, that's basically the number of legs, right? And if I quadruple the number of pigs, that's the number of legs from them, right? So legs and legs equals legs now. Cool. So guess what? This is a linear system. The C you spoke of here is the same C down here. The P is the same P, right? So let's solve. Do you want to do elimination this time? All right, so right now, if I were to add or subtract these equations, nothing goes away, right? Because nothing matches. What I'm going to do is I'm going to double the top so that I can get rid of C's. So this becomes 75 doubles is 150. Follow me? And you got to do it to every single term, right? We okay with that?
Won't you do negative?
I'm not going to do negative because I'm going to subtract these. I think your teacher last year probably said to add them every time, and that prevents a lot of little mistakes. You can do that. What I do is I just remember I'm subtracting. You guys forget that, and you start adding halfway through, and that's what screws you over, okay? So I'm doing 2c minus 2c. Gone. That's why I did it. That's why they call it elimination, baby. And then we've got 2p minus 4p is negative 2p. Again, remembering I'm subtracting here. I don't care that that says plus, right? I'm subtracting what this is. On this side, 150 minus 188. That's going to be a negative 38. So p is positive 19. Because 20 times 2 is 40, so 19 times 2 is 38. So now we've got the pigs, 19 pigs. Now, pause for a second. Why are we allowed to do this? Why are you allowed to subtract and add equations? No idea, right? Are you ready? I'm subtracting 2c plus p from this side. I better subtract 2c plus p from this side, right? But why am I allowed to subtract 150 instead? They're the same thing. So I am subtracting the same thing from both sides. It's just a different way of looking at it, right? Instead of subtracting 7 from both sides, I'm subtracting 7 and 3 minus 4, right? That's it. That's why this works. That's it. It's not a trick. It's just math. And again, I subtracted the other way around, but yeah. So now that I have p equals 19, I can solve by just plugging it in and finding out what c is. So I'm going to go back to the original where I had c plus p equals 75 because that's actually a really nice setup. If I know 19 is p, what number plus 19 gets me 75? Better question. What number plus 20 gets me 75? 55. So what number plus 19 gets me 75? 56. Sorry, I'm entertaining our video guests. How do you feel?
Good.
Yay. Did you know we're on the intermediate now? Oh, yeah. Who has the first box on the intermediate checked? You do? Okay, Shina's got it. But we should go over it anyway, because guess what? It's going to come back in a mean way, and I bet you don't have this one checked.
I don't have it.
Right? So either way, we should do it. So how do you solve a problem like Maria? Carefully. The whole point of algebra, guys, gals, non-binary pals, is to make a complex problem easy enough by just not changing it, but by looking at it in a different way. So you go, oh, that's the answer, right? Of course, right? Here, I don't know, maybe you think I'm pretty smart, maybe you don't, I don't know. But like, I'm all right. I can't look at that and go, oh, duh, 7, right? We need to mess with this so that it's easier to work with. So check it out. One of the strategies, one of the tactics you can do, and again, there's lots of things you can do, is to make this easier is to get rid of fractions. I'm going to times the top equation by 6 every single term, because when you multiply, you have to do it every single term. Let me show you why that is. 3 plus 4 equals 7. True or false? True. Imagine I didn't times every term by 2, but instead only times the 3 by 2 and the 7 by 2. 6 plus 4 is 14. No. But imagine I did double every term. 6 plus 8 is 14. Ah, yes. So do you see how this proves we have to times every term, right? Make sure you do. When I do this, I didn't do this to multiply, actually. We know how to multiply fractions. We times by the top, divide by the bottom. The reason I did this is because what is 6 divided by 6?
1.
Again, divide by the bottom, times by the top, any order you want to do it. And then we times 1 by 5s, and I get 5s. Already, this is looking better. Now I have a minus sign. What's 11 halves times 6? Well, 6 divided by 2 is 3. And 3 times 11 is 33. Do you see how that also got rid of the denominator? And it's because 6 is divisible by 2. I chose 6 because 6 is divisible by 6, 2, and 3. Gets rid of all of them. Sometimes you're not that lucky. Like we have 6, 2, and 5. Oh, okay. Might have to go back and get that. Or use a really big number, right? But here it worked out nicely. Then I have an equal sign. Do not, for the love of God, lose your equal sign. 6 divided by 3 is 2, and it's going to be negative 4r when all said and done. And doesn't that just look better? I'm going to use colors to keep myself organized so I don't plug it back into itself. The bottom equation, what can I multiply by to get rid of all those denominators? 9! I need to bring back the soundboard. So this is going to become this. This became that. When I times by 9, 9 divided by 3 is 3. 3 times 2r is 6r. Are you following me? 9 divided by 9 is 1, so I just get 28. Equal sign. 9 divided by 9 is 1, so I just get 8s. Okay. All right. Not too bad, right? As mathematicians, you need to notice things. That's one of the things you could have noticed. What can you notice now? Look closely. What do you see? And if you don't see it, that's okay. It's like an optical illusion. Once you see it, you can't unsee it. But I got to let you look first. It's annoying, but that's how it works. That's how learning happens, unfortunately. What do you notice about these two equations? In fact, I'll make it easier on you. What do you notice just about the pink one? Strong start. There you go. So why don't we divide everything by 2 to make it even easier to work with? Do you have to? No, there are no rules, but like easier is easier. I get 3r plus 14 equals 4s. Boop. Let's do substitution. I don't like elimination because you might do what Zoe Wyatt does all the time. Shout out to Zoe. And when you times things to match, like, oh, I want the r's to go away. I have to times everything by 3 and times everything by 4. Do you see how the numbers get really big? And it can get worse. So let's take these two equations, black and blue. Yeah. And let's get s on its own for one of them, or r on its own. I'm going to get s on its own. Is that cool? So I'm going to rewrite this as s equals 3r plus 14. And when we divide by 4, we have to divide every term by 4. We can do that individually or with the giant division bar. I prefer giant division bar. Do not try to simplify that. Just leave it alone. Because now we know what s is in terms of r. We can switch out s in the other equation, not the pink one. But we can switch out s in the other equation, and we get one equation with one variable, which means we'll be able to solve it using Algebra 1 skills. So, shout out to Algebra 1. 5 times the quantity of s minus 33 should equal negative 4r. And we know what s is in terms of r. S is 3r plus 1, 4 over 4. Yay. And while it's gross looking, at least it's one variable, right? It's all r's, which we can then get together, which is a great idea in math, but a terrible idea in real life. And then we can get r equals something. And if we have r, we get s for free. So now let's talk strategy. Could you distribute the 5? Yes, and you will. Then do you divide by 4? I wouldn't. I would times everything by 4 to get rid of that division. So I'm going to distribute the 5. I'm going to do it all in one go. 5 times 3 is 15r. Don't forget your r's. 5 times 14 is the same thing as 50 and 20, which is 70. Then I'm going to times everything else by 4. If I times this by 4, it gets rid of the division, right? So that's done. If I times 33 by 4, it's negative first off. 120 and 12 is 132. If I times this by 4, it's negative 16r. Are you smelling what I'm stepping in? I times everything by 4. That gets rid of the division here. It quadruples these guys. I distributed the 5 here. Now we have individual terms. We've expanded. And now we're going to contract by getting our terms together. So let's get our r's together. I'm going to add 16r to both sides. I'm going to do that. Some of you might subtract 15r. That's valid too. The reason I'm showing this one is because when you add 16r to both sides, guess what? This goes away and becomes 0 because there's literally nothing left. A lot of you guys get confused when that happens. Don't do that. Add 16r, it's nothing. There's nothing left over here. Write a 0. Don't lose your equal sign. If I'm adding 16r to this side to get rid of this, I'm going to add 16r over there. 15 and 15 is 30, so 16 and 15 is 31. R. 70 minus 132 is negative 62. Okay. So that means 31r has to equal 62 because I added 62 to both sides. Or you just use your brain. What minus 62 is 0? 62 minus 62, this has to be 62, right? So r has to be 2. Hooray for nice numbers. Sometimes it doesn't happen like that. So if r is 2, I can go and find out what s is if I know how r and s are related. And I do know how r and s are related. I have a really nice equation right here. Yay, substitution! Do you see how this is ready to go right here? Assuming I didn't goof. That's the same thing as all this, so why not just plug it in there and get an s? If r is 2, then we get 6 plus 14, that's 20. 20 divided by 4 is 5. S is 5. How you feel? It's weird, it's scary, it's different, it's stuff that you were supposed to learn in pre-algebra / algebra and you didn't because you were too busy getting the right answer or something instead of learning about strategy. But it's not that bad, right? Make it look nicer. That's the lesson. How do you feel? Moving on. D. How do we make this look nicer? For the love of God, please. Yep, in the top and the bottom, that'll move everything over 1 decimal spot, and then we'll have bigger numbers, but at least they won't be fractions. The top equation I'm going to use blue for. That's going to become 20y minus 30x's equals negative 32 minus 2y plus 1x. Before I mess with the other equation, I am going to combine like terms. I really hope this one works out nicely. I don't think it does. 22y, but we'll talk about what to do when things don't work out nicely. Negative 31x's equals negative 32. And there's no common factors I can take out to make that easier to work with, so I'll just leave it like that. Again, just working with that top equation. The bottom equation is already solved for y, so I'm thinking we'll be doing substitution. Y, when we times, well, it won't be when we times by 10, I guess, but if I times by 10 in the bottom, we get 10y equals 6y minus 10x plus 88. So here are our two equations. I'm going to play around with this one to get common terms together, like terms, I should say. If I subtract 6y from both sides, I get 4y over here. That goes away. I'm going to add 10x actually to this side before writing my equal sign and get 88. Pausing for station identification. What do you see? What do you see? There you go. So I can do some more work. Do you have to? No, there are no rules. But like, easier is better. Because that's the whole point of algebra, is to make things easy so you can think about it. Keyword being think. All right, so my new system is this guy and that guy. Okay? Same two equations, just different way of looking at them. Let's get y on its own, maybe here, I'm thinking, and then substitute. So that's going to be y equals negative 5x plus 44 all over 2. And if I substitute that into the blue equation, again, not plugging it into itself, that's why I'm color coordinating here. I feel like I'm in like opposite land right now. There we go. My face. If I take this thing there and I plug it into the blue equation for y, here's what happens. I get 22 times whatever y is, leave a space, minus 31x equals negative 32. And we know that y is negative 5x plus 44 all over 2. Are we going to distribute the 22? No, because what do you see? What do you notice? Hold on, Ella's like seriously missing? Like scary missing? Zoe, I can't hear you. Can you hear me? Is Ella seriously missing?
What, Mr. Mike?
Is Ella seriously missing?
Oh, are you ready? Turn off your Okay, so
I'm in
basically,
space.
one sec, I'm just gonna come in.
Oh, this sounds serious. Okay. While they're walking down here. Did you know that instead of timesing by 22, distributing, and then timesing by 2, we could just do 22 divided by 2, right?
Yeah.
So we get 11 times negative 5x plus 44 minus 31x equals negative 32. When you can do that, you should always do it because smaller numbers are better, right? So now when I distribute the 11, it's not as bad as it could be. I get negative 55x. 44 times 10 is 440, so 44 times 11 is 440 plus 44. That's 484. Is Ella going to be okay?
Well, I don't know where she is, but basically, she asked my mom earlier if she could go play with her friends at the Whiteside Park.
All right, and we're back. So, that's negative. I'm getting my x's together again. They're not adding over the equal sign. I'm just combining them, right? So that's negative 86 x's. And then I'm going to move this over there by subtraction. Negative 486. If I subtract 30 from that, it's going to be negative 516. Is that right? Ends in a 6. A 1. Yep. Okay. If I divide by 86, what number times 86 is going to get me 516? Well, if I had to guess, if it does work out nicely, 6 times 86 is going to be 480 plus 36. That works out nicely. Do you know why I guessed 6? Six times 6 is 36, right? So it ends in a 6, right? Or another reason is because that's about 100. 100 times 5 would get me 500-ish. But that's a little bit less, so maybe 6, right? Good guess. And if that doesn't work, then I know nothing does, right? Because it has to be in the ballpark, and it has to end in 6. So 6 is x, and if x is 6, guess what y is? It's negative 30 plus 44, which is 14? Yeah. Over 2, which is 7. Sorry, had a brain fart there. How do you feel? Gucci gang. All right. 523. This is the one that is a box that talks about like infinite solutions potentially, or no solution. You got them? Okay, good. Right? They're the same equation, or they're not. They're like literally the same equation except for one thing, and that means the slopes are the same, right? And then they're parallel. No solution. 531. Let's apply our skills here. These might be the hardest problems on the test. Like, they just, I don't know why. Well, I do know why. It's because we don't have the pre-algebra algebra skills that we were supposed to have, and that's not your fault. We don't have problem-solving skills, right? Because we've never been asked to solve problems. So, this looks nasty. Looks nasty, right? What can I do so it looks less nasty? Let's call this the red equation. What do you notice about the red equation? What can I do to make it look less nasty, you think? And if you're not sure, that's okay. But I have to give you the chance to think, because thinking is what teaches you. Yeah, we're going to save that for later, right? Do you notice we have a term here? I know it's not divisible by 5, but do you see how the top number is?
Yeah.
If I divide that by 5, I get 13x over 3x over 13. That's better. Can I divide this by 5? I can, because it's times by 5, right? So if I divide by 5, I get negative 3x over 13 here. And then there's just one term on this side, 5 times something, right? Parentheses mean treat it like one idea. So if I divide by 5, I get negative whatever 30 minus 5y is. Right? I divided out that times by 5. Cool? Let's distribute the negative. In fact, let's not distribute the negative. What if I times both by negative 1? It goes away, so I get 3x over 13 equals 30 minus 5y. I don't even need the parentheses anymore, right? Nice, nice. I can't divide everything by 3, so I shouldn't. I think now it's time to times by 13 and get x on its own, right? Let's times by 13. I get 3x on the side. I get 30 times 10 is 300. 30 times 3 is 90, so it's 390. 5 times 13 is 50 and 15. It's negative, so 65. And then all over 3. Success? Did we find her?
No. I haven't heard back from
So we know x is whatever this abomination is, right? Cool. Before we go plugging it in and rushing into this equation, can we clean it up first? We can. What do you notice? With your newfound knowledge, how could we clean up the blue equation? It's okay if you're wrong. We can divide everything by 2. This by 2, that by 2, and that by 2. So we get 2x over 13 plus 2y equals negative quantity of 2y plus 2. And once you do that, I want you to look at it again. You okay?
What? Oh.
No, you're good. I'm just talking to the audience. If that includes you, that's cool. If it doesn't, that's cool. I'm just waiting. Look at it again. What do you see now? We could divide by 2 again. Instead of treating this like a single idea, we could treat it like individual ideas and divide out of 2 from everything. X over 13 plus y equals negative y. I'm going to distribute that negative just to make it easier first. Negative 2y minus 2. If I factor out of 2, I get this. Are you following me on that? Cool. I think now I should get my y's together. And I get x over 13 equals negative 2y minus 1. I got the y's together and over on this side because I'm going to get x on its own. If I times by 13, I get negative 26y minus 13 is x. So if I know x equals this, and I know x equals that, then guess what? This equals that. That's one way of doing it. We could plug this in for x, right? If you do, you get 390 minus 65y over 3. I'm plugging that in for x equals negative 26y minus 13. Right? I just took that and plugged it in for x. X is by itself, so it, yeah, there you go. Again, if that equals x, then they equal each other. I'm going to times by 3 to get rid of this divides by 3. 390 minus 65y equals negative 60 plus 18 is negative 78y minus 39. Again, numbers big, but at least they're not fractions. And if I get my y's together, I'm going to add, so that's positive, and I get 13y That's a good sign. And then if I subtract 390, I get negative 429. And if 13 did go into it nicely, first off, the answer is negative. 10 times 13 is 130. 20 times 13 is 260. So 40 times 13 is 400. It's too big. So it's got to be like 30-ish. 30 times 13 is 390. That's close. That's 39 more to go. That's 3 more 13s. So guess what? 33. Y is 33, negative. And if y is negative 33, well, I don't have a nice equation to plug into. Oops. I could plug it into this one, I guess, right? It's not perfect, but I can plug it in and find out what x is. Actually, no, actually it is. X is on its own. Yeah, what am I talking about? So I get negative 26, negative 33. Again, that negative 33 came from here. I should probably do that in black. And then I find out what x is. It's whatever this abomination is. Honestly, if you got stuck at this part, you could just circle this. That's what x is. I'm done. Right? What is that? That's for you to figure out. Right? But I will do it. This is positive. 26 times 30 is going to be 25 times 30 plus another 30. That's 750, 780. And then 780 plus 60 is 840 plus 18 is 856. So if I take away 13, I get 843, which I assume is right. I know this is right. You know what I mean? Like, I know that's right. This is like, well, I hope I did my math right. My calculation, I should say. Math is not calculation. So, which is why, if you want to, just circle that, right? Like, I know we're good there after that. Depends on the day, right? Depends on the day. And I'm kind of a sleepy boy right now, so that's okay. And so are you. Do you know how to solve a problem like Maria? Yeah. Right? 3.75 is really 3 3/4. So what if we times it by 4 and we get 12 plus 3, which is 15? This times 4 is 15. You see it now? Good. Don't times this by 100. Right? Good. Let's not do it then. Let's not say we did. Are we taking off? Are we doing more? What are we doing? That's fine. I don't care. This is for you. You know what I mean? Like, you don't need to feel bad. Like, I'll go home and, like, sleep or something and then come back. But I'll do this too. Like, I plan to be here until 6. Describe all solutions. They're good? Okay. Right? If they're the same equation, then they're infinite solutions. If they're the same slope, so meaning the coefficients of x and y are the same, right? Then it's parallel, no solutions. Anything else is literally 1, right? How do you feel about 533? Right, if they're infinite solutions, then they have to be the same equation. What does A have to be to make a match, right? Eric and Bob?
Word problems, that's my name.
I felt like we already did that. Oh, it was Tweedledee and Tweedledum. That's what it was. Should we do these or no?
I heard my go.
All right, your call, man. Bye, Zoe. Bye, Eli.
I'm okay with what we've accomplished today, which has been a lot, so.
Imagine, if you will, that we did this like 40 minutes a day, 4 times a week for like 16 weeks. We could call it school.
Oh my god.
It would never work, but,
No.
right? So now you know for next semester, right? Did you know you can do what I'm doing without me being here? You have the solutions manual, right?
Yeah.
That's the thing. We don't have homework in this class, but we really do, don't we? Scooter, look who it is. How are you now, Scott?
I'm Pretty good.
Are you here to ask questions? Because my live studio audience, I think, is bailing on me. But if you're here, I'll keep going.
I was coming here to ask a question, mainly just to see how you do it so efficiently.
You don't have to flatter me, Scott. But yeah, I'll answer your question. What do you have a specific one in mind, like a specific problem?
Yes, very.
Okay.
Quiz 3, the infamous 10.1.6.
10-1-6?
10.1.6, yes.
Okay, I got you. Now you gotta picture a big country on there. Is Big Country with you?
I wish he was.
I wish he was too, man, because this is like his thing. I want to talk to him about this. Okay, I'll take care of it. Thanks. I can't smell anything, so I appreciate that. All right, 10-1-6, and we're talking basic or intermediate? It's basic, right?
It's an intermediate.
Oh, it's intermediate. Okay. Oh, I grabbed one where I already have notes. This must be the one I was doing earlier. Yeah, it was the one we did together with when Maya was here. 10-1-6.
It should be the first of the intermediates in quiz 3.
Okay. Why am I? Oh, I'm looking at advanced. God, sorry. Oh, okay, cool. Yeah. Let me get a clean one because we did this earlier. I cannot wait to show you this. All right. It's the three parentheses sets. Yeah. This is algebra 1.
Thanks, Scott.
I need algebra 2.
Hi.
All right. Okay, let's try this again. Sorry I'm taking so long, Scott. Here we go. Okay, so before we get into this, a little bit of a preamble. If I gave you 3 times 4 times 5, I can bet that you would not do 3 times 4 and then do 3 times 5 and then multiply them together. Right? You would just do 3 times 4.
I would not.
And then you would times it by 5, right? Same thing here. This is something times something times something. So you'll just multiply this and this. And then when you're done, you'll multiply it by that. Now, did you also know you could do 3 times 5 first and then times by 4?
I think so.
Okay, right. Multiplication, you can do it in any order you want, right? 2 times 3, same thing as 3 times 2, right? I'm going to show you this way because it's quick and dirty and it's kind of cool. And then I'll tell you that you don't have to do it this way. But this is kind of, you talked about efficiency. Do you notice that these are the same thing except they're opposite signs here and here?
I do.
Now, if you remember from the first part of the page, see you later, ladies. If we do things like this times this with opposite signs, the middle term goes away. In other words, we get x squared, we get positive 4x, we get minus 4x. See how that goes away?
Yes.
And then we get negative 16. So we get x squared minus 16. So because this one works out so nicely, I'm not going to multiply these two first. I'm going to multiply this one and this one first. And I'm going to get x times x, x squared. I'm going to get x times 4, that's 4x. Negative 4 times x, that's negative 4x. They cancel out, right? And negative 4 times positive 4 is negative 16. So already I've multiplied these two. So the last thing I have to do is I need to multiply by this guy. Now, could you have done these two first? Sure, but the middle term wouldn't have gone away, right? And you'd have to distribute that, which can be kind of messy. But when you have the opportunity, right, if you're clever, do these first. That way you have less things. Because now when I just do this times this. X times x times x is what that means. That's x cubed. Do you follow me?
Yep.
X times x times 3 is 3x squared. Then I have to distribute the negative 16 as well. That gets me negative 16x's. That gets me negative 10 times 3 is 30. 6 times 3 is 18. If I add those together, I get negative 48. And you see, when I did it this way, I don't have to combine like terms when I'm done. Because look, it's all condensed. Cubes, squares, linear, constant. That's what's nice about doing this first, rather than doing 1, 2, and then 3. Are you smelling what I'm stepping in, Scott?
I 100% am, and I'm definitely writing it down.
Cool. Now imagine this doesn't show up tomorrow as being opposites, right? You don't have that nice little way of doing it, so what do? Well, you can just do it like you would normally for anything. So the other way of doing this, Scott, is just x times x squared, 3x minus 4x minus 12. And we still have to times that by x plus 4, right? I'll condense this to x squared minus x minus 12. Are you following me on that, Scott?
I am, yeah.
And now, because we have a linear, like a middle term, a linear term, distribution is going to be a little bit messier. This goes to this and that. X cubed plus 4x squared. So, we get that. Because we have to distribute the middle term, I get negative x squared. I get negative 4x. And then I have to distribute the last term. Negative 12x. Negative 48. And when I combine all my terms, I will get this, right? But I have more terms because I had more terms to begin with. Does that make sense?
It does, yeah.
Right, yeah. So
But
when
both
you
answers would
can...
be right. Yeah, both answers would be right, but they're just at different stages to say, I guess.
Yes, absolutely. So when you see, as a mathematician, right, you get intuition over time. You have experience, right? If you see something like that, I would do this one first, right? It's kind of like when I give you 12 times 7 times 5. People might do it left to right, but if you have experience, you might say, I know this one's 60, and 60 times 7 is just 420. Right? That's easier than doing 7 times 12 first and then timesing that by 5.
Now, I really wish Salto was here.
Yeah, I know, right? So, again, it's just preference, right? And this is why I think this one's quicker, because we talk about efficiency, right? But both are fine. Like, you just distribute all the stuff, right? Do the first two, then distribute everything else. I don't know. Better?
Yes, definitely. Sorry, I'm still writing it down. I'm a little bit slow in that.
That's fine. My advice is watch the show and then I'll pause at the end and you can write everything. Or alternatively, if you were here, I would just take this to the copier and I'd make you a copy of this. You know what I mean?
I have her all written down now.
Cool. All right. Scott, was that your only question? Do you want to see some other things, or is that all I got for you?
Let me look through real quick.
Yeah, take your time. Take your time. I'm here until at least 6, so.
Okay, not so much a question, but for still on quiz 3.
Yeah.
For 10.1.3Q, it's on the first page.
Yeah.
For B, when on our quiz, this was x minus 8 multiplied by x plus 8.
Sure.
And I did not know, at least when I was doing this, I didn't know I don't know what I was getting at, but if I try to combine those two, if they just disappear, which
They
obviously
do.
would just leave you with some funny looking answer.
So this is exactly the same concept as what we just talked about here. Do you see how these two are opposite signs but same number?
Mm-hmm.
And I chose to times those together first. See what I got? See how the middle term's gone, right?
Mm-hmm.
So same thing here with the 8s. You can write it out and then see that they disappear, or you can just know it instinctively. I'm going to write it out. X times x is x squared. That's 8x. So far, so good?
Yeah.
Then if I distribute the negative 8 to both, I get negative 8x, which is why these go away. See how these are going to subtract each other?
Mm-hmm.
And then I get negative 8 times 8, which is 64, not 16. Got to be careful about that. So I get x squared. This is nothing, so it's gone. Minus 64.
I think my math went wrong somewhere.
Yep.
Because
I think I remember.
is that what you saw too?
I think
Because
so.
when I expanded, I had 8 squared plus 8x plus negative 8x plus 64. I don't know where I went wrong there. Actually, I do know where I went wrong. I can see it right now, right in front of me.
Good. And like, I know, like, we've done the portfolio and you already did the video and all that stuff, and we're going to figure that out. Again, don't sweat it so much, Scott. It'll be fine. But, like, that's exactly why we do the portfolio. To be able to sit down and be like, oh, I know where I went wrong. That is such a valuable skill. Oh, my God. That's like, forget math. That's just learning, man. Right? So, good. I'm glad you can see it. For this one, same concept, different numbers. X squared minus 4 is what we're going to get there. Because negative 2x and positive 2x will go away. And when these multiply, we get negative 4, right?
Mm-hmm.
Cool. Yeah, that's it. Now, notice this won't go away because they're not opposite signs. We'll get this. And notice negative 3x minus 3x is not 0. It's negative 6x. So that looks like more like a regular answer you're used to. Okay?
For mine there, on our last quiz-ish, I was so unbelievably close. I just had x squared plus 2x plus negative 2x minus 4, when it was supposed to be x squared minus 2x plus negative 2x minus 4.
I know, right? And like normally, Scott, like a normal math class would be like, ooh, minus a half or whatever, or like, you don't understand this. I know you do, right? And so if I've got enough evidence from the other problems to let me know that you know it, that's just a silly mistake. I write an S in my book, but you can get a check mark for that. You can. And if you had gotten this and that and enough evidence, I would have been able to just give it to you. So it's actually a better system because you don't have to be perfect to get a perfect score. You know what I mean? You can get that check even if you make little mistakes. Because I'm not testing whether you can do 2 times negative 2 correctly. I want to know, do you know what this means? Right? And clearly you do.
Exactly.
Yeah. Cool.
And probably for my last one, for 10.1.4Q, which is on the bottom of the page
right
there,
here.
when we took our first quiz-ish, I thought I was probably about the smartest man alive when I just took the only visible integers that we had there
Yes.
and just went 50 times 4,
Yep.
which is obviously 200.
Yep.
And then that worked.
Yeah. So do you know why it works?
Sort of.
50 times my number. So far, so good? Right? Is equal to the square of my number divided by 4. Right? So if I times both sides by 4, and the reason I'm doing this is because it's really hard to think of what this means, right?
Oh.
50 times something equals something squared divided by 4. That's a tough question to think about, right? But if I times both sides by 4, now the question becomes 200 times something equals something times something. And that's a little bit easier, right? What times itself is the same thing as itself times 200. And while it's a bit of a word salad, look at it. What's the only number that could go in for x to make both sides match? 200.
Obviously 200.
Right? So x has to be 200. There is another answer that's a little less obvious, but once you know to look for it, you'll be better off. The other answer is 0.
0.
Right? Because 0 times anything is 0 times 0. Right? And you know you need to look for 2 because quadratic. Right?
So would I be able to write something like that on a quiz-ish, something like what you had there, instead of going all the way through and, dividing it? I hate to say actually, like putting it to the test, but
No,
if
I get
know
what you're saying.
you had it,
Yes, because the most important thing in my class is thinking. And algebra, the whole point of algebra, Scott, is to make the problem look easy enough where you can go, and now the answer's obvious, right? Not to do all the steps and get x equals blank and then say, now I'm done, right? But to just to get it to a point where you can turn your brain on and go, boom, I know the answer now, moving on, right?
because looking at a past quiz-ish, let me yank the folder out here. It's way more work than what needed to actually be done.
But that's okay because part of problem solving is like throwing the sink at it. You know what I mean? Like you don't know how to solve it. That's okay. I don't give you problems. I mean, I do, but like on the first one, oftentimes you're getting problems that you've never seen before. In theory, you could have done them in the book. You could have looked at the answer key. You could have practiced beforehand for the quiz, but nobody does that. No offense. It's fine, right? But like problem solving is, I've never seen this problem before. How would I solve it? And to be a good problem solver isn't, oh, I remember. Somebody told me how to solve a problem like this. It's, how could I logic this? And you in Big Country are great at that. You're phenomenal problem solvers. You're great thinkers. What we got to do is just get you on track so that pays off. Like, if you had started turning on your brain in my class from day one, instead of like towards the end figuring out, ooh, I want to do this, right? You wouldn't have to worry about your grade at all. And I don't think you will either, Scott. I think you and Big Country are going to be fine. Fine is relative, right? We're not talking A or whatever, but like, you're going to be fine. And then next semester, look out. You guys are going to be dynamite, okay? We just have to get you going early so you're thinking, because you're actually great thinkers, and a lot of kids aren't. Okay, so yeah, if you can do a lot of work, I know that sucks, and it's like you're working really hard and you're working too hard, but like it's good. And then when I show you this, you're much more ready to learn about it, right? Because you're like, man, what do you do, right? You're asking that question, how do I do this? And you really want to learn. And as soon as you really want to learn, that's when students do learn. So Scott,
I think exactly
you're
what's
gonna be fine.
happening on 10.1.4 there is I would know the answer, but I thought that I would have to go through the vigorous steps of proving it.
Oh, vigorous.
Actually,
no.
Yeah, exactly.
No, not in here. Now, here's an example. I won't name names, but there was a problem on a quiz. It was an advanced problem. It's the last one on the quiz, and it's something about like Mary's favorite number and her mom's favorite number. And a student didn't do any work. They just wrote 420 and 69, and they were right because that was the version I made it for that one, right? It changes every time, but they got it right because they know me, right? So you need to show understanding. Sometimes just giving an answer isn't enough, right? But for a problem like this, no, that would be enough for me. Does that make sense?
Yeah.
Cool. How else can I help you, Scott? Anything else?
Let me take one more look-see.
Yeah, no rush.
This one, I think, is going to be just more, you'll explain it, and then I'll just feel a bit silly. But 10.2.1Q1, it is also on Quiz 3.
Yep.
Basic questions.
Yeah. Shout out to you in Big Country. You're working way too hard. Like, you're getting the right answer like half the time, which is insane. Let's do this. Okay, so this is a tough problem. You know it because you've tried doing it, right? You've tried to figure out what number times itself minus 10 times that number plus 9 gets you 0. And you're clever. You realize this has to equal -9, right? Mm-hmm. That way -9 plus 9 is 0. And so you're trying to think, how do I get this to equal -9? That's clever. It's a really tough problem. And if you can brute force it like that, that's good, that's healthy, right? But it should make you beg the question. It should beg the question. There's got to be a better way, right? And there is. If I can turn this into a multiplication problem, then the answer is much easier because if you know something times something is 0, turn your brain on like you were doing earlier. You know that one of these somethings has to be 0. Maybe it's 0 times 7. Maybe it's 8 times 0, right? But one of them has to be 0, right? Mm-hmm. So let's do that. How can I turn this into a multiplication problem instead of addition and subtraction? Well, that's what these are. These things right here. They're multiplication problems, right? And when you know that we're asking this, the answer is obvious. When x is 3, this becomes 0, because 0 here and 0 there. 0 times 0 is 0. Here, when x is 4/5, I get 4/5 minus 4/5, that's 0. Over here, I get 5 4/5, but who cares? Because 0 times anything is 0, so that's a winner. The other winner is -5, because I get 0 here, and who cares there? 0 times anything is 0. Are you following me?
I am.
Okay, so we need to turn it into something like that. Well, I know that when I distribute, because you know how to go from this to that, right? And from this or from that to that, right? Yeah. We're just going to go in reverse. How do I get that back to this, right? Well, you know that when I have this, they distribute and I get r squared from it, right? So clearly I need to start with 2 r's. Are you following me?
Yeah.
Okay, now you also know that when this number multiplies with this number, it gets us that. So if I go back to this page, see how this number, when I distribute it, got me this?
Yes.
These numbers got me my -8 and my -64, right?
Mm-hmm.
These numbers got my -4. So I need numbers that multiply here and here, that multiply to 9. I'll focus please.
There we are.
Well, we've got some options, right? 1 times 9 multiplies to 9, 3 times 3. So how do I know which ones I need? Well, also, think about this.
They also have to add to our -10.
Do you know
right?
why they have to add to -10?
So it can equal 0.
So
Right?
this times this gets me some number of r's, right? If there's a 5 there, I get 5r, right?
Mm-hmm.
And whatever's here will multiply here when I distribute for another number of r's, right?
Mm-hmm.
So I've got some amount of r's, some amount of r's. They should add to -10 so that this problem is the same as that problem. So I need numbers that multiply to 9 and add to 10. Well, how about these numbers? 1 and 9 multiplies to 9, so when I distribute here, I get the 9. And when I distribute here and here, I get 9r and 1r, which is 10r. Now, you might notice that we need a -10r, right?
Mm-hmm.
That's positive 9r's, that's positive 1r's, that'll be a positive 10r. So what I really need is this. Because -9 times -1 is positive 9, so it still gets me the 9. But now it'll get me -10r's. So in other words, this question is this question. And if I can solve this one, I get this one for free. Does that make sense?
Yes.
And this is an easy question to answer. Either of those will make this equal 0. Because when I plug in 9, I get 8 over here. But I get 0 there. 0 times 8 is 0. When I plug in 1, I get -8 over here. But I get 0 there. So 0 times -8 is 0. Those are my two answers. And if I were to plug those in here, 1 squared minus 10. That's -9, isn't it? -9
It
plus
is.
9. That wins, right? 81 minus 90 is -9. -9 plus 9 is 0. So all we're doing, Scott, is we're doing algebra. Algebra is about taking a complex problem and looking at it in a different way so we can see the answer and have it be obvious. When I get it like this, when I make that look like this, because they're the same thing, that is that, it's just easier to solve. And if you're not sure if that is that, you can always check. When I distribute r squared minus r minus 9r plus 9. And if I combine my r's, yes, this is the same thing as that. How do you feel?
I feel more understood. When we went through this, I want to say, I mean, of course it's going to be Friday, right? The last time we went through the quizzes,
Sure.
the days are just starting to get merged together.
Yep.
You know that feeling?
Me too. Me too.
The answer was, okay, so our question was different. It was r squared minus 14r plus 13 equals 0. And I think the proper answer ended up being what? Negative 13 and positive 1? I don't think that's right. I can't remember exactly. But I mean, I obviously, could solve.
That's the proper factorization because these will multiply to positive 13 and add to negative 14. Does that make sense?
Mm-hmm.
So our answers are 13.
I think another thing that I was doing wrong is erasing the sign before, for example, here, before 10r. Just erasing the negative and assuming 10r is positive itself, just like always.
Right, yeah, you got to look at the sign, right? There's a difference. Yep. Because if that was a positive 10r, I'd have double positives here, wouldn't I? Right? And then I have different answers. -9 and -1 would be the answers, right? So yeah, it does matter.
And what I had for the 14r one was r equals -1 and 14 positive 14.
Mhm.
And I didn't have the time while I was doing the quizish because obviously not trying to spend too much time on the problem.
Yeah.
But I noticed that it could not be -14 and +1, but I didn't go all the way to really check -1 and +14. But I just knew that under no circumstance would it be -14 and 1. I wish I could remember what I was thinking in the moment, but so much racking the brain during a quizish.
Yeah, sure, absolutely. I mean, you know this has to be -13 altogether. So -14 squared is going to be a gigantic number, and if we just times that by 1, we're just taking away 14. That's not going to be -13, right? We need this to be bigger than that, essentially, at the end of the day. But yeah, anyway. Yeah, you're a great thinker. You really are. Like, you have excellent logic. There are some people that try to be great thinkers, and what they're saying is just like a load of like made up garbage, and it's like, you know, like if we think of the three, if we think of the 3 as a mustache, and like it's just like, okay, but that's not reality. You're actually a good thinker. You really are. Do you understand this process and why we do it? Because it makes the question easier to answer?
Definitely.
Okay. Do you know how to solve a problem like part B then? Can I show you that?
Yeah, I got that right on my quizish last time.
Cool. Yeah, if we rearrange, right, it becomes just like the problem above. And then we need numbers that multiply to -18 and add to -3. So I need one positive and one negative, because multiplying to a negative, there's only one way to do it, right? Can't be double positive, can't be double negative, because those come out positive. So it's got to be one of each. So in other words, I need numbers that multiply to 18 and are separated by 3. Well, 9 and 2 are not separated by 3, so that's not going to work. But 6 and 3 are. And I need the 6 here and the 3 there, because while that gets me -18 either way, this, when I add them, -6t's, +3t's, gets me -3t's overall. Are you smelling what I'm
I
stepping
also
in?
definitely... Oh, sorry, keep going.
No. Are you smelling what I'm stepping in?
Yes, and I think I realized another problem that I had before.
Okay.
I don't know where this even comes from. This is the same thing as getting my X and Y's flipped up on 1 and then getting it right the next time.
Yeah.
I was multiplying to get -14R and adding to get 13.
That's what I was going to ask. When you told me up here that you had 14 and 1, I think you were multiplying to this guy, right?
Which would be correct.
Right. If that
you
were
were
what you were
those-
supposed to do, but you're not. And the reason for that is we're adding to this guy because, again, if you do distribution, you get that many R's, you get that many R's. That's going to tell you how many R's you have when you put them together, right? Getting all your common terms together. See how here I got like terms together? I did them by combining them, adding, essentially, right? 1 R and 9 R's is 10.
You circled my answer to that, -1 and +14, and put a smiley face under it, because I think you knew that I knew how to get it properly.
Yeah, and I should have written more there, man. Sometimes I get distracted and I don't come back to it. Like, I'll write a smiley face and I'll have to get up and do something, and then I'll come back and think, like, okay, on to the next problem. Yeah, I'm sorry about that. I should have written more clearly. That's my bad, Scott.
Definitely no problem.
Yeah, because you probably thought, oh, it's good to go.
I mean, I could just tell what we were getting at once I saw that it wasn't right, but
Good. Okay. Yeah, I didn't do that on purpose, Scott. That was a mistake. And I don't try to do that. Yeah, that's not on purpose. That was a mistake. I should have done a smiley face and written something else. I didn't mean to mislead you. That can be very misleading. Yeah. So, are we feeling better? Do we understand the concept now?
I believe we are.
Okay. Last thing, this one, just use your brain. So this is like a prime problem for you in big country. Think about this. This is how I teach algebra, Scott. I don't like do weird things. We just think about things. What's 196? 196 minus what is 0?
Wouldn't it just have to be another 196?
Yeah, exactly. So you know whatever's underneath my pen is 196. So apparently y squared is 196. Because otherwise it wouldn't equal 0, would it?
Mm-hmm.
So what number times itself gets you 196? Well, it turns out this one's actually a nice answer. It's 13. Or sorry, not 13, 14. But if you didn't know, you could say y is the square root plus or minus of 196. Because when you take a root times itself, like, what's the root of 25?
5.
And if I times it by the root of 25, you know that's 5 times 5. 25, right? Do you see how a root times itself is just the number inside? That is y. So when I times it by itself, I get the number inside. This is a valid answer. And notice it can be positive or negative. Do you know why this works out positive or negative?
Because something negative times itself is going to be positive?
Exactly. So not only is 14 an answer, negative 14 is. That's what this simplifies to, but I will always accept this. Totally fine. Okay?
Okay.
Is that all, Scott?
Yes, it is. Unless you would like to see my cat who is sleeping at the moment.
I would like to see your cat very quickly, and then I'm gonna join your cat, not at your house because that'd be weird, but I'm gonna go home and sleep at my house.
Tell me if you can see.
Oh, not sleeping right now.
No, we kind of woke her up.
Gotcha. Sorry. What's her name?
Tipsy.
Tipsy. That's a great cat name.
The reason we named her that is when we found her on the side of the road, quite literally.
That's where we got ours.
She does this thing where, to show affection, she'll kind of just like fall on you. So kind of just like teeter over on herself.
I've got one
and
like that.
we called her Tipsy because it seems like she was drunk, you know?
Sure, right. That is a great name and a great reason for having the name. I also saw your shirt. I forgot. Like, sometimes I forget the Scott I met last year is the same Scott I know this year, right? And you are into all kinds of dope music. So, yeah, we need to talk music more often. Unfortunately, like, math class is just too crazy and too busy to really sit down and get to know each other. But, yeah, I forgot. You're that Scott. You listen to dope stuff. And you got a cool cat.
Did the Yeezus shirt help you jog your mind?
Yes. I remembered, like, yeah, this dude likes hip-hop. Like, not, like, just rap, but, like, hip-hop. Like, proper, knows his stuff, deep cuts. So, yeah. Cool kid. Cool kid. Anyway, I'm going to go home and sleep. Cool? Uh-oh. Did I lose you, Scott? Oh, now you're back.
My Chromebook died, and I am now on my phone.
Gotcha. Well, anyway, I was saying how cool you are because you listen to deep cuts, right? You know hip-hop proper. And that's what I like about you. But anyway, I'm going to go home and sleep, dude.
Much. I've been thinking, I mean, obviously have, but about putting maybe any of the music I really like to enjoy on our class playlist, but with how large the variety of people, I can just say that broadly, the vast majority of people, I don't know, the taste is incredibly different in that class, and I can
Right. I
definitely
mean,
tell.
that's why I don't try to put my songs on it either because it's just like they're not ready. You know what I mean?
Yeah,
They're not ready, right?
Great point.
They're not ready.
They're
for
not
it.
ready.
That's okay. They've got to go through experiences like you and I did so that when they hear it, they go, that's music instead of going, that's noise. Right?
Great point, yes.
Yep. Well, Scott, I appreciate all the effort you did to get back on. But if you're done, I'll go home and sleep unless you got more questions.
I am done and would like you to go home and sleep.
Wonderful. Scott, I'm so glad you tuned in. And good luck tomorrow. Get some sleep yourself, okay?
I will. Thank you very much.
Good night, Scott.
You good luck tomorrow.
Thank you. I'll need it. I'll be running around like crazy. Bye.
Have a good one. See you tomorrow. Thank you very much.
Mm-hmm. Well, that was fun. Let's upload this video. What a page turner. Lots of interesting events happening, huh?